Hello, my name's Mark, I'm with Gcode Tutor, and I'm here today with Practical Machinist to look at how we're going to program a complete part from start to finish. So we're going to start off by looking at the header in this lesson, and then next month the video lesson will be how we do the roughen cycle. So stay tuned and let's see how we set up this bush. So the first thing we need to do is have a look over our working drawing. So this is the part that we're going to make. So looking over the dimensions, they seem easy enough to hit. I've not listed tolerances here because we are just writing the Gcode program, which would be mid limits throughout. Then we would use our offsets to adjust to hit those tolerances perfect on each section. What the drawing has not stated here is there is no chamfers or edge breaking going on. So we're going to add that to our program as we program this part. I'm going to go through and add small chamfers to each edge just to break that sharp edge there to save us problems with deburring after the part is made. Okay, so let's start writing this program by starting with the header information. So the first line we need is the program number, and the program number looks like this, and yes, that's a trailing O and not a 0 at the beginning there. So it's O and then a 4-digit number which lists our program number. Now if we're writing this offline, we might have to start with a percentage symbol, or we might have to start with those dots there at the beginning. And this is because when we start writing a program on FANUC, it normally adds that information in for us. It normally gives us our program number followed by a description of the part. Now talking about the description of the part, we list that in operators brackets right after the program number, and we finish with a semicolon there to say that's the end of block. So anything in brackets is not read by the machine, purely read by the operator, and that's what this video is about. We're going to lay out a header full of operators notes so we don't need to rely on setup sheets so much. We can see exactly what's going on just by looking at the start of the program. Okay, so the next line I want to look at is identify the programmer. Now I do this so if there's any mistakes or errors or anything that needs adjusting within the program, they know who programmed it and they know who to come to get those changes done. So another operator's note with the programmer there, finished with an end of block semicolon after each line as always. I normally like to add the date. This gives us an idea of whether there's any revisions done to the program. So if we updated this program in a year's time, I would add another section underneath date saying the last time it was updated so we can keep track of the latest program that we have for this part. I normally put what machine we're using on there as well, because we could write a program for one machine, put it on the exact same machine next door to it, and it might not run. So it's good to state what machine this program was originally made for, and then if it ends up uploading to a different machine, we can be very aware that to watch that first cycle to make sure that's okay before we leave it unmanned. So I like to break up my notes with a semicolon quite a lot, and you'll see this quite a lot through my program. It makes it easier to read, it breaks things up into readable chunks. It's almost like paragraphs when writing a book. So it sets everything out so we can more easily see what's going on. So I've just added a semicolon there to break up the top information where I've got the programmer, date and machine, and then we can look at our tooling information. So this is a subheading, tooling. So all the information under here is what tools we're going to be using on this part. So next time we set it up, we can use the exact same tools so we can guarantee the same surface finishes and dimensional accuracy. Okay, so let's have a look at our first tool. So the first tool we're going to want to come in with is a tipped right hand roughing tool, a right hand knife tool. So I'm going to pop this in tool 1 position with offset 1, TO1 and the offset 01. With the operator's note of what the tool is afterwards, so I'm just saying roughing tool here, and then I've listed an N number. And we're looking to N numbers as we go through the program. I use them as search functions and subroutine functions, but we'll look into more of that as we use them in the program. But for now, no, we can type N1 on our controls on FANUC, push the down arrow, and we'll search through the program to the roughing tool because it's going to look for that N1. Now, with the tips of our tools, I like to list what tips and holders we have under each tool. Now again, this makes it easier to set up. We know exactly what tool the operator wanted to use when he first designed this tool. So we can go straight to the drawer, pick up the right tip, pick up the right tool, load it in the machine, and we can be pretty confident that we're going to get the surface finish and the dimensional accuracy that the program expected. So we list our tips. I'm using a Sandvik tip here for this one, and I'm also listing the tool holder underneath to make sure that the operator knows exactly where to get these things from and where they go in the machine. So we know that's going in position 1 of our turret there. So we're going to want a finish turn tool. So I'm popping this in position 2 of our turret and using offset 2. Now I'm not going to go in and list the tip and holder for each tool. I'm just doing it on the first tool just so you know how I normally operate. We're just going to run through these now without listing those tips and holders. But when you're doing this on your machine, I would advise you to do that. It makes it much easier to set the job up next time. So as we go down, I'm going to center drill this part. So we're going to rough turn it, then we're going to finish turn it. We could finish turn it at the end. We could drill all the holes first and then finish turn it on the last op before we part off. And if we were machining nylon, I probably would, but we haven't decided what material this is. So let's assume it's aluminium or steel, and we won't need to do that finish and turn after the drill. So tool 3 is our center drill. I'm using the BS number 2 center drill for this, and we're just going to come in and center the beginning of this bore here with that. So once we've center drilled it, we're then going to come in with a 15mm tin coated drill. So I've added more information here about the type of drill that we're using. Maybe I've experimented and tried different drills and found this one cuts the best. So I've listed what that is down there also. So in tool 4, we're going to use a 15mm drill. And tool 5 is a boring bar. I'm going to want to break that edge at the front of the bore, maybe at the back of the bore as well, and give a good surface finish and high dimensional accuracy. So for that, we're going to need to use a boring bar. Now again, I've not listed the type of boring bar or the grade of tips, but you would do that under there also. And then finally, we're going to part off to size. I'm not going to use sub spindles for this. We're not going to use work catchers. We're just going to part it off to size, let it drop in the bottom of the machine. So we're going to assume this is a hard material that's not going to chip if we do that. So just for ease of use, we're going to use a parting off cycle, and I might just come in and take off that break edge there. We might come in at 45 degrees and come down. We will see when we get to that stage. So that's the parting off tool done. So that's all of our tools that we're going to use for the process of this job. So that's 6 operations in total. Now again, I'm using an end of block there just to say that's the end of the tooling, and now there's another section coming up with information that we're going to need. So the final bit of information I put on my header before I start writing a program is how long the initial pull-out length is. Now remember, this is a turning program. We're on a lathe here, so we have some stock bar and we're going to pull it out 40mm from the end of our collet chuck. We're going to just measure that with a ruler and then close the chuck. Now that's our initial starting position. As the program progresses, it will automatically pull out that bar to that length further in the program. So we only need to do this on the first run, but it's nice to have a note there so the operator knows exactly how far to pull that material out. The other option would be to start the program, bring the roughing or finishing tool over to Z0 and then pull the bar out to meet that. So I like to normally start with a pull-out length. So with that information we've listed in the header, the operator can tell what tools to use, what holders to use, what tips to use, where they go in the machine, and how I set it up for those tools originally. So it's much easier to run, and if the setup sheets are not available, or maybe your shop doesn't use setup sheets, all the information can be put in the header to make sure that the job is run correctly. Okay, so if you enjoyed this lesson, I have a whole bunch more like this over on my website at gcodetutor.com. I have a full article section full of free information and a lot of paid courses teaching you how to program Gcode, CAD-CAM and machine shop maths. So pop over and have a look.